In this video we'll talk about Hinge theorem and how it applies to triangles. So, Hinge theorem is, at its core, a pretty simple idea. Basically what we're looking at is if we have two different triangles where two of the sides, or two pairs of sides, are congruent. So let's say we've got triangle ABC, and let's just say, for the sake of the sake, X, Y, and Z. If I know that AB is the same as YX, and I know that AC is the same as YZ, well then what we can determine is some things based on the angles and these sides across from the angle, made up by the two congruent pairs of sides. So the idea is very simple. If angle A is less than angle X, well then BC, the opposite side, has to be less than YZ. And it actually turns out it's an if and only if statement as well. If I know BC is greater, then angle A must be greater. So basically, if AB is congruent to YZ, or YX, forgive me there, and XZ is congruent to AC, well, then we can say that angle A, if angle A is less than angle X, if and only if BC is less than YZ. So basically, if I lock in these two pairs of sides, basically the bigger angle is going to be across from a bigger side. That's what the Hinge theorem says at its core, and the more you try and write it, and a lot of times in writing that's where it loses its translation. But if you lock in two of the sides of a triangle and allow that angle to change, a larger angle results in a larger opposite side. So to help put this in context, a lot of the uses for this would be if we're looking at, say, this example up here. If I wanted to be able to talk about these two sides, compare them, well, I have to make sure that Hinge theorem applies here, which it does. I have a side of 5 meters, so this side's congruent, and then a side of 7 meters, which means that those two sides are congruent. So then I can look at the angles here. This one's a 32-degree angle, this one's a 90-degree angle, meaning that this side here is bigger. It has a greater distance than this one. So it's kind of similar to, the idea with triangles or angles in one triangle. The biggest angle is always opposite of the biggest side. So if I lock in two of the sides, then I can look at the angle, and if I'm comparing two triangles, that's what Hinge theorem is useful for. Now the part where I said it's an if and only if, I can also make comparisons about the angles if I know about the sides. So if I look at this example on the bottom, I have technically two pairs of congruent sides, and the last side is not congruent. So this would allow me to say that this angle on the left has to be smaller than the angle on the right because of the 9 versus the 10, the opposite side. So this is the smaller angle because technically it has a smaller side opposite of it, and this is a bigger angle because it has a larger side across of it. If I'm comparing between the two triangles, this angle on this 10 triangle must be greater than the one with the 9. And that's Hinge theorem at its core.